Today, on Math Expressions, we will learn what multiplication and division are and how they are used in the real world. Plus, we'll also look at a multiplication chart from 0 to 9, and we will also explore patterns with 2's. Hello there, I'm Dot, I'm Dee, and I'm Del. And today, we are going to have some fun with math. Ooh! These problems are kind of interesting. Oh, you're right, Dot, they are. What are those problems? That's a good question, Del. These are all multiplication and division problems with 5's and 2's. Oh, yes, of course, multiplication and division. Darn. Quick question, Dot. What is multiplication? And what is division? That's a good question, Dee. And that's a good question to you too, Del. I'll be more than glad to teach you. Multiplication is a mathematical operation that combines two groups. For example, let's look at these 5's multiplications patterns over here. Okay? For example, if we have 6 bananas and we want to combine 5 groups of 6 bananas, then we will have 30 bananas total. So 6 times 5 would be 30. Wow, cool. What's that dot between 6 and 5? Oh, the Dot is very awesome. She's a great sister. No, I mean, what is that little dot between the numbers 6 and 5? Not dot as in her. Oh, that's a good question. Well, that black dot over here between the numbers 6 and 5 actually represent the multiplication symbol. Oh, that's what it represents. But why in some problems there's a snowflake and there's an X instead of a dot? Well, because a snowflake and an X are two other completely different ways to represent multiplication. You could represent multiplication in any way. Oh, yeah. I think I kind of understand now. Let's try. Yes, let's try a few problems together before we actually dive in. Okay, let's do this one. Okay, Del, what kind of scenario would you explain if we will do 1 times 5? It could be any scenario. Okay, I'll take your banana scenario. It's very helpful. Okay, scenario away. All right now. So, Dot, what? If we have 1 banana and there are 5 groups of 1 banana, then we will have 5 bananas? That's correct, Del. Because, for example, if we draw 1 circle and then we draw 5 groups of 1 circle, that would give us 5. Oh, that's how multiplication works. I get it. But, what about division? That's a good question. Well, division is a mathematical operation that takes away groups. It's like multiplication because it's opposite, but this time it's taking groups away. Oh, so you're saying multiplication combines groups, but division takes groups away? That's correct. Like, for example, if we have 20 apples and we have 5 groups of 20 apples. Wait, not 5 groups of 20 apples. Let's try that again. All right. Anyways, if we have 5, okay. If we have 20 apples and we divide the apples into 5 equal groups, 4 apples will be in each group. There, I explained it better, sorry. It's fine. Sometimes we make mistakes all the time. Yes. Go on, D. Practice and see if you can get it right. Okay. What about this one? That's a very good one. Wait a second. 2 of the numbers are the same. That's right, D. And I was just about to say, if you if you divide by the same number twice, you will always get 1. All right, D. Okay, so 5 divided by 5 is 1, right? Yep. So if we had 5 oranges and we divide the oranges into 5 equal groups, 1 orange will be in each group. That's correct, D. It's also the same with 2s, but it's very different because it's not 5s anymore, it's 2s. Like, for example, let's do 4 times 2 together. So, if we picked 4 carrots and we divide... Oh, wait. No, this is not division. This is multiplication. Silly me. Anyways, if we picked 4 carrots and then we have 2 more groups of 4 carrots, then that would be 8 carrots altogether. Oh, I think I get it now. But what about the 2's divisions? Wait a second. I noticed something. What is it, D? Some of the problems have the division sign, but why do some of the division problems have a slash over them? That's a very, very great question. The division sign is one way to represent division, which is the most common side, but a slash is also another way because it can indicate a horizontal fraction. Like, it could be 10 divided by 2 equals 5, but it could also be 10 halves, and that would equal 5 as a whole number. Oh, yeah, because I already know about fractions and whole numbers, but not just this. Okay, and now I know. Let's try one together. Good idea, D. Okay, so if we picked 16 bananas this time, and we divided the bananas into 2 equal groups, 8 bananas will be in each group, right? That's correct, D. Now try the slash ones. All right. If we have 2 halves of a pie, that makes 1 whole pie, so it's 1. Or if we picked 2 apples and we divide the apples into 2 equal groups, 1 apple will be in each group. That's also correct, D. Do you guys get it now? Yeah, I think we're ready to do the math lesson. Okay, here goes nothing. All right. Write your name and the date here to get started. If you are watching this video, say, today is November 29th. If you're watching it tomorrow, which is November 30th, just write that date. But only if you have the student activity book. Otherwise, if you don't have the book, then it will not make sense. All right. Let's see if we can solve this one. Oh, there's an unknown blue box here. That's correct, D. We have to solve it. Oh, okay. All right. Let's look very hard on this problem. Let's try to solve it. All right. 5 times 3 equals what? Okay, so if we picked 5 carrots and we picked 3 more groups of 5 carrots, then that would be, I just can't remember. Don't worry, Dee. There's a very easy way to represent a multiplication problem, and that is to draw a model, aka groups of the carrots. What is a model, and what are groups? That's a good question, Dee and Dell. A model is not just a picture, but it's a picture and words below it that describe it or explain what's going on. Groups, which Dell asked, groups are little frames that substitute, like, let me show you. So, like Dee said, if you had 5 carrots and we picked 3 more groups of 5 carrots, those 3 5s would be groups because we picked 3 more groups of carrots. And this would be one group. This would be a 5 frame. So a 5 frame like this and 3 5s like this are both groups. So let's draw 3 5s of carrots. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. There you have it. 3 groups of 5. Okay, Dee. Count all the circles and see if you can solve it. Okay, I'll try my best. Good. All right. So there are 3 groups of 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The answer is 15. That's right, Dee, because look, if we put 3 groups of 5 carrots, then if we count them all, that would be 15. It's the same thing as 3 number 5s or a 5 frame, because that would help. So the answer is 15. And by the way, 3rd graders, if you got that one right, well done. I'm going to be so proud of you. But if you got it wrong, don't worry. At least it's a nice effort. Speaking of that, getting it wrong is actually okay. What? But it's wrong, and that's bad. Well, just because a problem could be wrong doesn't mean it's bad, because if you make a problem wrong, that just means you're making a mistake, and mistakes grow your brain so that you can learn from mistakes. Oh, that's cool. Yep. So anytime you make a mistake, you just have to know they grow your brain and you can become smarter. Wow, I didn't know that, Dot. Yes. All right. Ooh, this is a division problem. 18 divided by 2. Let's see if you guys can try to solve this one. Okay, so I'm going to be writing 18 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There we go. 18 circles. So, with my pencil here, I'm going to draw groups. Okay, so if we had 18 circles and we decided to split them into 2 equal groups. Let's count the circles in each group, kids. Let's count the circles in one group. 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer's 9. That's right. Yep, that is totally right, guys. And you're right too, D. It is 9. Because look, if you had all these 18 apples and you just circled 2 groups, 18 circles, not apples. If you had 18 circles and then you decided to circle 2 groups, if you count each dot, not each dot, if you count each circle in only one group, you will get 9 circles in one group. So 18 circles divided by 2 equal groups will equal just 9 circles. So with your pencil, kids, write 9. Number 2 is 9, and number 1 is 15. So if you got them right, good job. All right, number 3, complete the multiplication sentence. Ooh. 5 times 6 equals 6 times what? Huh? But 5 times 6 equals 6 times what? But I thought when you solve a multiplication problem, you just solve it right away. Yeah, D, like 5 times 3. But this time, it's not a multiplication problem, it's a multiplication sentence. So we need to find the opposite. So 5 times 6 equals 6 times 5. What? How is 5 times 6 equal to 6 times 5? Good question, D. We just flip-flop the numbers around. Because, look, 5 times 6 and 6 times 5 are the same. We just flip-flopped the numbers. The whole multiplication sentence will not change if we flip-flop the numbers 5 and 6 around. It will still make sense and it will still be the same. All right, question 4. Ooh, this is actually a word problem. Oh, I love word problems. Let me tackle this. Okay. Andy uses 3 bananas in each of 5 loaves of banana bread he is baking. Write a multiplication expression to represent the total number of bananas Andy uses. Oh, we have to write a multiplication problem. That's right, D. So, if the numbers 3 and 5 are in the word problem, and it says to write a multiplication expression, what would you write? 3 times 5. That's right, because it says to write a multiplication expression to represent the total number. But if we divide, it's not the total. It's getting less. So it would be 3 times 5. Kids, if you got number 4 right, well done. I'm so proud of you. Wait, Dot. You forgot to do something. You forgot to solve the problem. That's right, D, because it's not even an equation at all. What? But it has a multiplication sign, and it has 2 numbers in it. Why can't it be an equation? Good question. It's an expression. So it can't be, like, solved. What is an expression? Good question. An expression is a special kind of equation where it has 2 numbers and more or equal to 1 operation, but no equals sign. So that's why an expression is a special kind of equation where it does not have an equal sign. You just write it. Wow. I can't believe it. Math is so amazing. Yep, it is. The last problem. 5. Solve to find the unknown number in the equation. 5 times what equals 40? Okay, let me tackle this. So if we picked 5 carrots and we combined how many groups of 5 carrots, we would get 40 carrots. That's right. So let's draw it in our model. So, if we have 5 carrots, and we combined how many groups of 5 carrots, and then we get 40. Let's draw groups until we stop at 40, okay? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. All right, we're at 40. Now let's count how many groups there are. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 groups. So the unknown is 8. So 5 carrots times 8 groups of 5 carrots will give us 40 carrots. Yippee! Great job, kids. Boy, you sure are smart. And I just don't know how smart you really are. Alrighty now. Let's look at this. This is interesting. What is it? Yeah, what is it? Good question, guys. This is a multiplication chart. It can help you solve math problems. For example, let's point at 5. And then we multiply by 7. We'll just go all the way down until we see 5. So 0, 1, 2, 3, 4, 5. So 5 times 7 would be 35. And that would be your product. Wait a second. What's a product? That's a good question. A product is the answer to a multiplication problem. For example, if you point on 0 and if you multiply by it, you will get 0. Oh! So if you multiply 0 by itself, you will get 0 as the product. That's correct. And the 2 blue square numbers, like 0 and 0, these 2 numbers are factors. Factors are numbers that help you get the product or the answer to a multiplication problem. For example, in our problem, 5 times 7 equals 35, 5 and 7 are factors because they multiply and combine a random and unknown group to try to make up the product of 35. Oh! So if you say 9 times 9 is 81, both of the 9s are factors because 2 of the 9s help you get the answer or the product of the multiplication problem. That is correct. All right. Now, I have one last thing I want to share with you kids. This is a pattern rectangle or square, whatever it is. Wow, it's so cool. Yep, it is a pattern mat exploring patterns of 2. Ooh, hey, that rhymes, 2 and ooh. Anyways, this is the path to fluency. So this is your opportunity to learn at fluency. What patterns do you see below? Let's see. Let's turn it the other way. All right. Yeah. What patterns do we see below? That's a good question. So, this is 2 equals 1 times 2. And that equals 1, 2. So 1 times 2 is 2. And there's only 1, 2. So there's only 1, 2 pattern. Then 4 equals 2 times 2. So 2 times 2 is 4. That would be 2 2s. That would equal 2 plus 2, which equals 4. 2 is equal to 2, and 2 plus 2 is equal to 4. So if 2 times 2 is 4, 2 plus 2 is 4. And if 1 times 2 is 2, then 2 is equal to 2. Oh, I get what you're saying. Because, like, if we do 10 equals 5 times 2, that would equal 2 plus 2 plus 2 plus 2 plus 2 5 times. So if 5 times 2 is equal to 10, 10 is equal to 2 plus 2 plus 2 plus 2 plus 2 5 times. That's right. It's a whole triangle of 2's. They're like steps going down. And there are even more patterns. Like these little blocks that go this way. Oh, I see the blocks. What are these? These are groups of 2. They're trying to tell you that they're counting by 2's. 1 2 makes 2. Another 2 makes 4. Another 2 makes 6. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Then it goes on like 22, 24, 26, 28, 30, 32, 34, 36, 38, all the way to 100. Oh, I get what you're saying. Like if we go here, it's 72, 74, 76, 78, 80. That's how you count by 2's from 72 to 80. That's right, D. Well, everybody, I guess it's time to go, and I guess the math lesson is over. Oh, but it's okay. We will learn even more new stuff another day. Yes, that's enough math for one day. Phew! I'm Dee, I'm Del, and I'm Dot. And we will see you on Math Expressions for another day. And remember, with mathematics on your side, always question, always wonder.